Hello everyone. In the previous video, we have learnt about the hyperbola and its standard equation. And also we have found out how to find the length of lattice rectum. Also we have learnt about the derivation of the equation, that is standard equation of the hyperbola. In this video, we are continuing the same and we will be learning about the conjugate hyperbola, its equation, and also we'll be learning about the rectangular or equilateral hyperbola. And also we will be discussing some of the problems based on the standard equation of the hyperbola. So here we see conjugate hyperbola. As we have seen, the standard equation of the hyperbola is x square upon a square minus y square upon b square is equal to 1, in which the center was at the origin and the transverse axis was along the x-axis. Here in this conjugate hyperbola, we find that the transverse axes are along the y-axis and the conjugate axis will be along the x-axis. The center here also is the origin. Why? Because we are finding the standard equation. What is it of this line on the y-axis? These are a and a dash. The coordinates of a are 0, a, and that of a dash are 0, minus a. Now what about the foci? The focus, two focus. That is S and S dash. The coordinates of S are 0, AE and that of S dash 0, minus AE. As we know that AE is also represented as C, we can also write this as 0, C and this as 0, minus C. Now what about the directrices? Directrices here will be parallel to the x-axis and that will be y equal to a upon e and y is equal to minus a upon e. Now what about the transverse axis? As we have learned that transverse axis is along the y-axis and the length of this will be equal to 2a as it has been in the previous, that is standard hyperbola also. The conjugate axis, which is along the x-axis now in this conjugate hyperbola, and the length of that will be equal to 2b. The standard equation. As we have seen here that the x and y or transverse and conjugate axis have interchanged. So in the equation also x and y will interchange. And the equation of this will be y square upon a square minus x square upon b square is equal to 1. Or we can also say it is x square upon b square minus y square upon a square is equal to minus 1. We are to learn here that the relation between a and b is same here also, that is b square is equal to a square into e square minus 1. And e is greater than 1 for hyperbola, that we know. Now, what about the lattice rectum? The length of lattice rectum will be same as it was there, that is equal to 2b square upon a. Now we learn about the rectangular hyperbola. What is a rectangular hyperbola? In case we find that a hyperbola is such that the transverse axis is equal to the conjugate axis. It means the length of both the axes are equal. Then we say it is a rectangular hyperbola. This also is known as the equilateral hyperbola. What about its eccentricity? See, we have seen just now that in case of a rectangular hyperbola or equilateral hyperbola, we find that the length of the transverse axis is equal to the length of the conjugate axis. It means 2a is equal to 2b. It means we can say a is equal to b. Or we can say a square is equal to b square. And we also know that b square is equal to a square into e square minus 1. Do we find that this a square and e square cancel? It means we are getting 1 is equal to e square minus 1. By transposing we get e square is equal to 2. Or we can say that e is equal to root 2. That is positive. Why? Because e is greater than 1 for hyperbola. So we can remember that in case of an equilateral hyperbola or the rectangular hyperbola, we find that the length of transverse axis is equal to length of the conjugate axis, and also the eccentricity is square root 2. Now we'll be going for some of the examples based on the standard equation of the hyperbola. The first example here is find the equation of the hyperbola whose vertices are plus minus root of 11 by 2 comma 0 and the foci are at plus minus 3 comma 0. For the solution of such problem, first of all we have to see whether it is the first type of hyperbola or it is a conjugate hyperbola. We find here that the vertices are plus minus root 11 by 2 comma 0 and the foci are plus minus 3 comma 0. Both are lying on the x-axis. Both lie on x-axis. Therefore, the equation of hyperbola will be the standard equation, that is x square upon a square minus y square upon b square is equal to 1. Now we also know that the vertices of this are given as plus minus a comma 0. Do we find from here that a is equal to root 11 by 2? And also we know that the foci are given as plus minus ae comma 0. So we find here that ae is equal to 3. So we have already found the value of a. It means a square will be 11 by 4. To find out p square, we know the formula b square is a square into e square minus 1. Or we can write this as a square e square minus a square. Or we can write this as ae whole square minus a square. What is ae? We know it is 3. So this is 3 square. Minus a. A is root 11 by 2 and a square is 11 by 4. Is it 9 minus 11 by 4? This is 4 9 are 36 minus 11, 25 by 4. After finding the values of a and b, we can substitute in 1 to find out the equation of the hyperbola. So we can write therefore equation of hyperbola is x square upon a square means a square is 11 by 4 minus y square upon b square is 25 by 4 is equal to 1, which can be written as 4x square upon 11 minus 4y square upon 25 is equal to 1. This is the equation of the hyperbola whose vertices and foci are given to us. The next example we have, find the length of the axis, foci, the eccentricity and the length of latus rectum of the hyperbola 16x square minus 9y square equal to 144. See, the equation which is given to us is 16x square minus 9y square equal to 144. If we divide this by 144, we will be getting x square upon 9 minus y square upon 16 is equal to 1 or not. This is the standard equation of the hyperbola. In this, what we find? We are finding here a square is equal to 9. and b square is equal to 16. If we compare it with the equation x square upon a square minus y square upon b square is equal to 1. It means we are getting here a is equal to 3 and b is equal to 4. Now what are the lengths of the axis? So we can say therefore the length of transverse axis, that is equal to 2a. It means that is 2 into 3, or we can say 6 units. Similarly, the conjugate axis, that is equal to 2b. It means 2 into 4, that is 8 units. Now we have to find out the eccentricity and the foci. We know that b square is equal to a square into e square minus 1. Substituting these values, we are getting 16 is equal to 9 into e square minus 1, which gives us e square minus 1 is equal to 16 upon 9. Or we can say e square is equal to 16 upon 9 plus 1, which is 25 upon 9. This gives us e is equal to 5 upon 3. Now we can find out the foci, and we know foci are given by plus minus ae comma 0. That will give us plus minus a means 3 into e means 5 upon 3 comma 0. 3 cancel. This comes as plus minus 5 comma 0. Now what else we have to find out? We have found the length of axis, we have found the foci, we have found the eccentricity, that is 5 by 3, and now we have to find out the length of latus rectum. We know length of latus rectum is given by 2b square upon a. Substituting the value, we are getting 2 into b square is 16. A is 3. So this comes as 32 upon 3 units. This is the length of the latus rectum. Like this, we can find out the elements or the parts of any of the hyperbola if the equation is known to us. The next example we have is find the equation of the hyperbola whose vertices are at 0, plus minus 3 and the foci are at 0, plus minus 5. What we find here, the vertices are 0, plus minus 3 and foci are 0, plus minus 5. Do we find that these both are lying on the y-axis? Both lie on y-axis. It means this is a conjugate hyperbola. This implies that it is a conjugate hyperbola. Let the equation be y square upon a square minus x square upon b square is equal to 1. We already learnt what is the equation of the conjugate hyperbola. Now we know that vertices are 0, plus minus a. This implies that a is equal to 3. Also we know that the foci are 0, plus minus a into e or plus minus c. It means we are getting here c or ae is equal to 5. So we have got the value of a, that is 3, implies that a square is equal to 9. We have got the value of ae, that is 5. It means we can find out the eccentricity, but we don't want that, we want only b. So we know that b square is equal to a square into e square minus 1. If we substitute the values here of a square and AE. It means we simplify this. This will be A square E square minus E square. This is AE. AE means 5 and the square of 5 will be 25 and that of A square, that is 9. 25 minus 9 is equal to 16. So we have got the value of A square and also we have got the value of B square. Now substituting this we can find out the equation of the hyperbola. So we can write therefore equation of hyperbola is x square upon b square minus y square upon a square is equal to minus 1, or we can say y square upon a square minus x square upon b square is equal to 1. Any one we can substitute. If we apply this, we are getting the equation as x square upon b square is 16 minus y square upon a square is 9 is equal to minus 1. If we take the LCM here, we can also write this as 9x square minus 16y square is equal to minus 144. This is the equation of the hyperbola according to the given value. In the next video, we will be learning about some miscellaneous problems on the conic sections. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.